Welcome back. This is section 11.1 on torque. 11.1 is also this section in your book. The whole chapter is on the rotational equilibrium, whether something or not will rotate or turn on its axis or pivot point. And this first section we're going to be looking at is the idea of torque. So torque is kind of like a force. It is anything that can make something pivot or turn or rotate. So we're going to see that it's a turning force. Now forces can't be applied in a turn. There's no turn, there's no like curved way that I can apply a force. I can only apply a force straight. So for instance, if I have a pivot, let's say I have a seesaw, and I apply a force here, that is a force. I could say sit on it, and that would be my Newton weight would be the force that would cause this to turn. The idea of torque is a little bit more. It is the idea of a force and a lever arm. Okay, so we could say that as the distance. So a force multiplied by how much of a lever arm away from the pivot or the fulcrum that I have. So we'll see that, let's say that this was much farther and I apply the force. Do you see that force is going to have more or less impact depending on how far from the fulcrum that it is. So the entire thing is going to, the force times the lever arm is going to allow you to turn it, not just the force, because for instance, if I put the force here, nothing would turn. Do you see? So it's a little bit more complicated than just a force, but it's a force and a distance. So essentially you're doing work. If you think of force and distance as work, you're doing work on something that can then have an effect as moving, say, a door or a seesaw or something. So you use torque all the time. A doorknob is torque. The door itself is torque since there is a rotation around the hinge. If you tighten a faucet or you use a wrench, all of these are providing a force that then has some kind of an arm to move, a lever arm to move that causes pivot or turning or rotation around a pivot point. So this lever arm, that's where you get the adjective or the noun leverage. Leverage is how much of a lever do I have? So if I have more of a lever, if it's longer, say if my doorknob is longer, it wouldn't take as much force to open a doorknob. So a doorknob that's actually long and skinny handle rather than a round handle is actually easier to use. Even little children can open a door that has a handle that has a torque bar to it. So it's some kind of a leverage. Now you know that a hammer can pull a nail, but a crowbar can pull a nail easier because essentially the turn of that hammer has been magnified in the length of the crowbar. So the lever arm adds, or the force is applied to this lever arm to make a turn or to make a rotation. So this is a good picture. Why do you put the doorknob on the side of the door? Okay, so if you have a door, here's your hinges. Why is the doorknob on the side? Why is the doorknob not in the middle? Why is the doorknob not on the other end of the door? Because it's farther away from the hinge. Here's the pivot. This is where the door is turning. And the farther away the doorknob is, as you push the doorknob, let's say you open the door, so you unlatch the door, and now you're using the knob to push the door open. It's an easier push when you're pushing from the edge than when you're pushing closer to the hinge. The closer to the hinge you move, the harder it would be to open the door. So when you have a hobbit door, okay, with the doorknob in the middle, okay, I suppose it depends on where the hinge is. See, the problem with a circular door, and why I guess it's so cute, is because no one ever has circular doors. First of all, where do you put the hinges? You don't have a hinge, you don't have a way for the door to pivot, and if you do have a way to the door to pivot, okay, let's say that the pivot's actually in here somewhere, you don't want a doorknob so close to the pivot that it's so hard to move the door, especially if the door is big. You want the handle to be as far away as you can to make it easier. So the idea of where you're putting the force. So if the hinge is here, if this is the hinge, your force is going to be at a lever arm. So you're exerting a force. You're exerting a force on one side of the door, and then it will rotate at the hinge. So your formula for torque is a force, any force, the newtons of force, times some kind of a lever. So the lever arm is a distance over which that force is going to exert. So you can kind of see work here. Force times distance is a torque, or is a work. And so torque is the work done on one side that's causing a pivot. So if you have a teeter-totter, you're going to have work done on one side making it pivot counterclockwise, and then you would have work done on the other side, which is making it pivot clockwise. And the whole idea is that it's balanced in such a way that you can move without a whole lot of frustration. Since torque is basically the idea of work, you can have a large force acting at a small distance, or you can have a little force acting at a big distance. It really doesn't matter. You want it to be as easy as possible, so normally you don't want the force to be required to be big. So like a door, you want the doorknob as far away from the hinge as you can, so that your force opening the door is less. Same idea. I like this picture. Where do you put the force? Okay, the force has to be perpendicular to the lever arm. Now that's absolutely important. Any force that's not perpendicular to the lever arm is not causing rotation. It will cancel out somehow. So if you're holding your hand here, do you see that some of this is actually acting away from the pivot and is not causing rotation at all? Only some of it is acting up, and that part of your force is making torque. So for instance, if the nut is too tight and you do not have enough strength to pull it there, if you were to make your hand at 90 degrees, you would be exerting more of your energy towards putting torque on it. And if you extended it somehow, okay, simply put something hollow around that wrench to lengthen it, then you've got, the longer the lever arm is, the more the same amount of work. So you're still turning that screw, but it's less force required. So if you're not strong enough, extend it. The longer your lever, the easier it would be for you to turn it. I love this picture. See if it tricks you. I bet you it'll trick you. Would this length of rope, if I extend the lever arm, I can make it easier to pull. Would this length of rope help you? Okay. Yes or no? Make a guess. The answer is no, because this is not the lever arm. This is the lever arm. To make it easier, you would have to extend this higher, and then if you pulled on it, it would be easier. Okay? It's the idea of how far is it from the pivot? How far is the lever arm from the pivot? Okay? So, believe it or not, the easiest door to open would be the widest possible door. Now, if you could get it on the hinge, and I guess it would weigh more, so I don't know how much force would be required to open a very wide door. But the wider the door, the easier it would be to push open. That's pretty cool. So, do you know it? How do you make an object turn or rotate? You apply a torque, and a torque is a force acting on the rotating object at a distance, which is called a lever arm. So if you want something to pivot around this, you would exert a lever arm and then exert a force at 90 degrees to that lever arm.